I need you. I'm just going to erase that. That's terrible, but. Okay, I'm going to need you to sketch a straight line. I'm going to use this to help me out. Okay. What I want you to do is I want you to sketch negative, it's excessively large, negative 176 degrees, and I want the reference angle. For this question, yes. So that's for question 1. Question 2, I want you to simplify. Two root 24 plus 3 root 54 minus 7 root 128 plus 3 root 98. Those are your first 2 questions. And go. Work. Okay, so what's the first catch of this? It's a what angle? It's a negative angle, so I have to go what direction? Clockwise. And I'm going to label clockwise. So I'm going to go 0, 90, 180, and by 90 I mean negative. Negative 180. Make sure you have degree symbols. Shh. Do you have degree symbols?
I do.
Okay, negative 270. Because if you don't have degree symbols, it's radians, and you don't even know what that is. So that's a problem. Okay. Now we need to go 176. So we have to have an initial arm. Make sure you have an initial arm, a terminal arm 2, and a rotational angle. So 176 is about 4 away. So it's going to be really close to here. Let's pretend that's straight. Okay. So we would draw our arrow this direction to say it's actually clockwise, and it's negative 176. My reference angle is the bow tie angles. The bow tie angles are the angles between the x-axis and the terminal arm. We agree? Always. X-axis and terminal arm. So what is my angle here? What's this going to be? 4. And my reference angle is always positive. So my reference angle is 4 degrees. Always positive. Even if the angle is negative. Always positive. Okay? All right. Now we're going to simplify these. What do we have to do? We have to first make them all mixed radicals, which is all grade 10 math. It even comes up in the curriculum in grade 11, but we assume you know it from grade 10. We've practiced it a lot, so hopefully you do. What perfect square can I break 24 into? 4 and what, Nick? 4 and 6. The 4 comes out and it's a 2, so we get an equal sign running down the left of this. Why do we get an equal sign running down the left? Because they all are equivalent. Yeah. I heard booklet, then realized you said equivalent. Which is, I'm just old. It's not you. It's me. Okay. So we get 4 root 6. All right. 54 breaks down into what, Rihanna? What and what? Does 54 break down into anything?
Yeah.
What?
9 and 6.
9 and 6. Coming at you for this one, Rihanna. Okay. So we're going to go 9 and 6. The 9 comes out, and it is a... This is math class, not the weekend. Okay? It's real it is.
Did you know he was thinking...
Not talking about the singer. Knew you were going to go there. Fun fact, Monday.
Able. Just able. Just like... Just kidding.
Okay. All right. 3 times 3 is 9. Root 6. Hey, Rihanna, do you know what the 128 breaks down into?
16 and 8.
Even bigger? 64 and?
2.
Yeah. You could do 16 and 8. It would totally work. You take out the 4, and then you just take another 4 out. Okay. So we take 64 out. It's an 8. And we get minus 56 root 2. Mitch. What about the last one? Root 98. 49 times 2, root 49 is? 7 times 3 is? All right. So can this all simplify to one radical? Is it able to simplify to one radical? No. Can it simplify to two radicals? Yes, because we can put together like radicands. So 4 root 6 plus 9 root 6 is 13 root 6. 56, negative 56 root 2 plus 21 root 2 is negative 35 root 2. Done. All right. Yep. We don't. Number 3. You're trying this one out. I don't.
I didn't see the one.
He has a little bit of. It's the C's. The C's.
What?
COVID and
Concussion?
yes. That made you not see the one.
I'm so lost.
Okay. It's the C's.
The C's.
Okay. Number 3. I'm going to give you a trig ratio. Actually, first I'm going to give you a coordinate. I'm going to give you a coordinate. It is at negative 4, comma 6.
What?
Yep. Negative 4, 6. I'm in the same thing. I have the C's. Negative 4, 6. And I want you to determine, bless you, the angle in standard position which you're going to have to get the reference angle first. And reference angle, you always use the positive. So I want the angle in standard position. And then I want the 3 primary trig ratios. What does that mean? SOHCAHTOA, yeah. 3 primary trig ratios. And your x flux. Sign your residue. Quick extra x. Okay, so that's 3. Now 4, I'm going to make you multiply radicals. Which is what we did on Friday. Okay, so we went over this. I've been able to give you a coordinate, and then I asked for standard position and the trig ratios. And then after that, I gave you a trig ratio and asked for standard position and a trig ratio. He's hungry. He's not going to chug the root beer. I will never let him leave again. He is going to regret it.
Go back there.
Okay, so we need to, what's the first thing we always need to do? Starts with D, rhymes with raw. Draw the coordinate. Don't know where you guys are going with that, but it is draw. Okay, negative 4. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It's here. And I drew it there so that I could see the actual angle itself. So I know the angle is going to have to fall between 90 and 180. Right? I know the angle should fall between 180, negative 90 and 180. And if I get the reference angle, I can just go 180 minus the reference angle and I get the angle. Correct? Now, how do I get the reference angle when it's a coordinate? It's always tan. Because it's tan your x flux. Do you agree? And I always take the what? To get the reference angle. The positive. So I'm going to go tan theta, tan your x flux. So it's 6 over 4. I didn't do 6 over negative 4. I did 6 over 4 because the reference angle, you always do the positive. When you do that, what do you get for a degree? You have tan negative on both sides. 56. So theta, reference angle, theta equals 56 degrees. Does that seem realistic to kind of where it's drawn here? Yeah, it seems realistic. I put the 56 degrees in. It will be here. So how do I get this angle? In standard position? 180 minus 56, and what do we get? 124. Now, how do I get the three trig ratios? Now it does matter about the sign, correct? But what do I not have in this triangle? I have a triangle. I'm going to take the triangle off. It's like this. And it is 4, x equals negative 4, y equals 6. I don't have the r. How do I get the r? Pythagorean theorem. So I'm going to go r squared equals 6 squared plus negative 4 squared. So r squared equals 36 plus 16. So r squared equals 52 square root, and we get plus or minus, but r is always what? Positive. Can I break down 52 into 4 rad 13, which breaks down into 2 root 13. So I know r is 2 root 13, and then I can do my trig ratios. So I'm going to go sign your resume. Sign your resume. So your is 6 over 2 root 13. What did I tell you have to do when you have a square root in the denominator? Multiply by it. You're going to rationalize the denominator, which is actually what we're doing today in our lesson. So we're going to multiply by root 13. When it's just a monomial, you multiply by just the root. So we're going to get 6 root 13 over 26, because it's 2 times 13. And then I can take a 2 out of both. I get 13 here and 3. So it's 3 root 13 over 13. Then we do cos theta. Cook extra rice. So it's negative 4 over 2 root 13. Once again, I'm going to rationalize it. Root 13, root 13. So I get negative 4 root 13. And then root 13 times root 13 is 13. 13 times 2 is 26. And I can take a 2 out again. So I'm going to get negative 2 root 13 over 13. And then tan is the nice one, because it doesn't have the root 13. Tan your x box. So it's 6 over negative 4, which I can take a 2 out of both, so negative 3 over 2, or 3 over negative 2. It's the same thing. So that's if we're given a coordinate. The only one we're not going to review today, but we will review tomorrow, is if I give you a trig ratio instead of a coordinate, so tan, sine, or cos, and then I make you find the standard position or the other two primary trig ratios, right? This we did on Friday. I wanted to see what you would do if I actually put a little bit of extra onto the back of it, because that would just use polynomial rules from grade 10. We'll see what you did. So our first step is to distribute into the bracket. When I hit an end bracket, we were taught we do what? You stop, correct? So I'm going to put the 3 root 2 into those two, and then I'm going to stop, and then behind it I'm going to write minus 4 over root 98, or minus 4 root 98, right? It doesn't get distributed in because it's not in a bracket. So we're going to put an equal sign, because this question doesn't have an equal sign. So I have to run an equal sign down the left, because this equals this equals this equals this. So I'm going to get 3 root 2 times 4 root 2. 3 times 4 is 12, because coefficient times coefficient, and then radicand times radicand. Root 2 times root 2 is 2. In brackets, remember? So we always go that in brackets. And then we multiply again. 3 times 6 is 18. Root 2 times root 3 is root 6. And then I have minus 4 root 98. Root 98 can break down into what and what? 49 and 2. And the 49 comes out and it's a 7. So we get 24 plus 18 root 6 minus 28 root 2. And then people freak out. They're like, it must be better. There's nothing better. 24 is its own term. It's constant. 18 root 6 is a root 6. 28 root 2 is a root 2. Can't collect like terms, but we're all collected, right, as much as I can. So I just box it. I'm going to get you guys to flip to your notes, the radical notes, and you will be on page 6.
Yeah. What were the Philippines doing?
Really? You did not.
I did.
There's no way. Chad was joking, okay? He was not.
Yeah. No. And I'm making.
All right, so we have task 1 is divide. Now, you were taught this particular one in grade 10, but we're going to go over it anyways. So you were taught in grade 10, yes, you were slightly taught division, but it always worked out like this. So you were taught that what you can do is you can either treat these separately, so I could break down 20 into 4 root 5, etc., right? Or if the numerator and the denominator are divisible by each other, you can write them, or even if you want to just do this, you can write them as a full radical. So you can either take a full radical over a fraction and split it up into separate radicals, or you can take separate radicals and split them up as a full radical. So I can rewrite this as 20 over 5. Now why would I do that? Because 20 divided by 5 is a nice number. We agree? It's 4. Square root of 4 is 2. So we can actually do this. We can do this all the time. But there's certain times when you should. You should do this when the two numbers are divisible by each other. Okay? So root 20 divided by root 5 is root 4, and the square root of 4 is 2. And I have the answer. If you don't do it that way, you're going to have to rationalize the denominator. Colton, you're ready. Yeah. Sugar crash, he just pounded. He's crashing. Okay, root 90 over root 15. I can reduce these, or I can say, hey, root 90 and root 15, 15 goes into 90 evenly, correct? So I'm going to write it as a whole radical. Root 90 over 15. How many times does 15 go into 90? So it's just root 6. You can't get any better than that, because it wouldn't be an exact value. Okay, what about C? C is root 45 x cubed over square root 5x7. X is greater than 0. Now the reason why we say x is greater than 0 is because if x is a negative number and you raise it to an odd exponent, you're going to get a negative underneath this radical, which is illegal. Because you can't take the square root of a negative number.
It's illegal?
It's illegal. Because you can't take the square root of a negative number. Like root negative 4 isn't possible. Root 4 is 2. Root negative 4 is imaginary. It doesn't exist. You can't take the square root of a negative. So, these ones I would write under one radical because 45 divided by 5 is a nice number, right? And then the x cubed divided by x7 can work out to something nice as well. So I'm going to go root 45x cubed over 5x to the 7. And so I'm going to get square root. What's 45 divided by 5? 9. And what do I do with x3 over x7? That's taught in grade 10 too. What do you do when you divide? You subtract the exponents. When you have two bases and you're dividing, you subtract. So we get x to the 3 minus x to the 7, or x3 divided by x to the 7 is 3 minus 7, which is negative 4. So we get x to the negative 4. But we're not going to leave it a negative exponent. How did I tell you you can make a positive exponent? You take it from up here, and you bring it down here, and it'll change it to positive. And you'll see why that's important. Because we can't take the square root of a negative, but we can drop that down to the bottom. You were taught that in grade 10 as well. So I can write this as the square root of 9 over x to the 4. Why didn't the 9 move to the bottom? Why didn't the 9 move? Is the negative 4 attached to it? No. Its exponent, the exponent on the 9 is a 1, so it doesn't need to move, right? When there's no exponent on something, it's just a 1. So what's the square root of 9? 3. What's the square root of x to the 4? x to the 2. You try the try. If we want to write it as a full radical, we'd have to go x over 4. So we can't write that as a radical. And then we would go 18x cubed over 6x. So we get x over 4. What's 18 divided by 6? 3. And then what do I do when it's x3 over an x? Minus them. So what's 3 minus 1? 2. So I get x squared. Can either of those reduce, the 3 or the x squared? The x squared, there's 2 of them, right? So I can take 2 out for 1. So these can come out as an x. So now I actually have x squared over 4 square root 3. So we do the whole entire radical situation deal when they work out nicely, when it's like 18 divided by 6 or 25 divided by 5 or something where it's a nice number, correct? But we're going to look at task 2. And task 2 says rationalize the denominator, which means no radicals in the denominator, which none of these had radicals in the denominator after we did what we did. But you're going to see the difference in these ones. So this one is 8 root 15 over 5 root 2. If I made that an entire radical, it would be 15 over 2. Is that nice? No, it's a decimal. So instead of actually making an entire radical, we're going to do what we just did in trig the whole time. How do we get rid of that root 2 on the denominator? Times by root 2. So could we have done that here to get rid of the root 6x? Could we have just times it by root 6x? Yes. We don't actually have to do the previous method. That previous task 1, you can spot it because it's sometimes faster and easier, but you don't ever have to do that. You could always just do this. Rationalize your denominator by multiplying by what's in the radical. So I'm going to multiply by root 2 in the denominator and root 2 in the numerator. So I'm going to get 8 root 30 over 5. And then what's root 2 times root 2? 2 in brackets. Remember? So can you actually divide radicals if you can't multiply? No. Dividing radicals is the easy part. You just literally go, okay, I need to multiply by that root. And then the rest is multiplication. Right? So can I reduce 30 in any way? No. So I'm going to get 8 root 30 over 10. And then what can I do? Take out a 2. So this is a 5. And this is a 4. So we get 4 root 30 over 5. You're going to do the tries and the next one and the next one because we've kind of done these ones already. So 10 root over root 3, what are we going to multiply by? Square root 3, top and bottom. Okay, so this one we're going to multiply by root 3 and root 3. So I'm going to get square root 30. And then root 3 times root 3 is 3. Can I do anything better to that? No. I'm done. C, quiet please. C is 25 over root 75. Now you can just go right away and multiply by root 75, but you're going to have some big numbers, right? Or you can break the root 75 down, which is what I'm going to do. I'm assuming you didn't do, and that's totally fine, but I just want to show you what it would look like if you did reduce them. So I'm going to break root 75 down. So I'm going to go 25, and then root 75 is 25 times 3. When the 25 comes out, it becomes a 5. So now I have, don't go erasing yours, we'll get the same answer. 25 and then 5 root 3. And now, once I have it reduced, I can multiply by the root 3. So if I multiply by root 3, I get 25 root 3 over 5. And what's root 3 times root 3? 3. So 5 times 3 is 15. And then I can take a 5 out, I'm going to get a 3 and a 5. So if you did it the other way and you reduced properly, you'd still get 5 root 3 over 3. Same answer. You should have the same answer. Everyone get that? Just went a different way. Totally fine. D is 5 root 21 over 7 root 70. So we're going to get some big numbers here. So do I have to multiply by the 7 or just the root 70? Just the root 70, right? Because root 70 times root 70 is 70, so I don't have to multiply by anything else. So I multiply by root 70, multiply by root 70, and I get 5 root, what's 21 times 70?
1,470.
1,470 over 7 times 70 in brackets, right? 1470, what does that break down into?
49 and 30.
39 and 30. The 49 comes out, it's a 7. And then 70 times 7 is 490. So I'm going to get 35 root 30 over 490. I can take a 5, actually I can take a 7 out of, can I take a 35 out of both actually?
Yeah.
Yeah, what's 490 divided by 35? 14. So 35 divided by 35 is 1. 490 divided by 35 is 14. So I get root 30 over 14. The last one we're going to go over today, we have a different type tomorrow for dividing. Because right now, all I'm doing is getting you guys to divide with a monomial radical, right? If you flip over to the next page, you'll see what we're doing tomorrow. So see how there's a binomial radical? Now there's a plus and minus sign in the denominator. Changes how we do it. Okay? But we're just sticking with this way today. So let's look at task 3. Task number 3, we're not going to do any different because the binomial is not in the denominator. The binomial is in the numerator. So we have root 3, a is root 3, minus 1 over root 3. So I don't care that there's a binomial in the numerator. All I care about is I'm rationalizing the denominator, which means I'm getting the radical to go away, right? And how do I get rid of a root 3 in the denominator? I multiply by root 3. Nothing's changed. It's still a monomial. So I'm going to multiply the top and the bottom by root 3. The only catch now is that if you look in the top here, I'm going to have to do what? Distribute that root 3 in, because there's a binomial now. Up until now, we've only had monomial numerator, monomial denominator. Now we have a binomial numerator, so we have to distribute. So this is going to equal, we have an equal sign running down the side because there's no equal sign in the question. And when there's no equal sign in the question, you run an equal sign down the left. So, what's root 3 times root 3? 3. Then what's negative 1 times root 3? Negative 1 root 3. Do I have to write the 1 in front? No, I'm going to leave it there though. Because it doesn't matter if I keep it there or if I get rid of it. You don't have to put a 1 in front, it's multiplying by 1. What's root 3 times root 3? 3. Now, does this not look like the end of a quadratic formula question? Does that look like the end of the quadratic formula? Where I have to look for the triangle numbers and see if I can take something out of all 3? It's the exact same. Is there something I can take out, except they have a plus or minus sign, it's quadratic. But it's still the same thing. You've stuck 3 terms, right? So it has to come out of the triangle. Can I take a 3 out of all 3 of those? No. I have a 3, I have a 1, I have a 3. Remember, I can't cross off out of here, right? I have a 3, a 1, and a 3. There's nothing I can do. I box it and I move on. How do people mess up? They think you can simplify more. They cannot. If it was like a 3 and a 6 and a 3, then go ahead, right? Okay, let's look at B. We have 6 root 2 plus 2 root 6 over 3 root 6. What do I just have to multiply by? Just root 6, not the 3, right, Colton? Yes, just nod. Okay, good. So, we're going to get root 6 here, and then root 6 up here. Try it out. So for this one, we're going to distribute, and we're going to get 6 times 1, because the coefficient of this one is a 1. So we're going to get 6. Root 2 times root 6 is root 12. Let me distribute this one. 2 times 1 is 2. And then root 6 times root 6 is 6 in brackets. Over 3 times 1 is 3. Root 6 times root 6 is 6 in brackets. Now this 12, can I reduce it at all? Break it down into 4 and 3. The 4 comes out as a 2. And we get plus 12 over 18. And so I'm going to get 12 root 3 plus 12 over 18. And what can I take out of all 3 of them? Can I take something out of all 3? A 6. So I'm left with a 2, a 2, and a 3. So my answer is 2 root 3 plus 2 all over 3.
Slightly complicated.
Did you just say he's slightly competent?
That was not even close to what he was trying to say. I heard competent. I knew he was trying to say compliment.
A compliment.
It didn't sound like that. It sounded incompetent.
It was like slightly competent is what I heard.
Oh.
Compliment is much nicer. Okay.
No, because you're saying this is why you don't get compliments.
Oh, okay, that isn't nicer. Okay, so we have 18, root 18x minus root 8x, and then over root x. So we're going to multiply by root x and root x. Okay. So when I distribute the top, I get root 18x times x. So the x's join together. And so I'm going to get root 18x to the 2, because the x times the x is the x squared. Minus root 8x times root x is 8x squared. And then root x times root x is just x. And then can I reduce the top? Yes. So 18 I can break down into 9 and 2 and then x and x if I want. The 9 comes out as a 3 and the 2 for 1 special of x's. So these two come out as 1x. Done. Done. And then 8 I can break down into 4 and 2 and then x and x. The 4 comes out as a 2 and 2 for 1 x's. All over x. And so on the top I'm left with 3x square root 2 minus 2x square root 2 over x. Am I done? I have root 2 and a root 2 in the top. I actually have like terms. So 3x root 2 minus 2x root 2 is just x root 2 over x. And then what can I do? Cancel off the x's. I'm just left with root 2. It's crazy. We don't worry so much about the other one. I'm just going to give you some questions. This is a very big size, right? I understand. Okay, so page 290. Number 6, 7a, 8ab, and 11b.